Welcome! This video is on Controvol, a tool designed to assist in NoSQL application development. Let's say we're building an online role-playing game. This is our setup. To the left is the development environment. As developers, we're building a first version of the application with lots of cool features. We commit our code to a code repository and when finished, deploy the application into production. Our production environment to the right is cloud-based. The application is hosted on Google App Engine, a platform as a service framework. It persists its data in a NoSQL data store, such as Google Data Store. We're an agile team and iterate on our application. Already, developers are working on the next version, adding new features. Again, we deploy the application. The new application also persists its data in the NoSQL data store. If the data store is schema-free, it can handle both the legacy and the new data objects, even if they differ in their structure. This flexibility in handling heterogeneous objects makes NoSQL data stores very attractive in agile software development, but it also brings about new challenges. Let us have a closer look. To the top left, we see a screenshot of the Eclipse IDE with the declaration of the Java class player. An object mapper persists player objects. This is declared by the annotation entity in line 6. Each player object has a login, a name, and a level. In between releases, a developer renames attribute level to rank. Eclipse consistently updates all references to this attribute. However, this affects the application code only, but not any persisted objects in production. So what happens if the new code is deployed? The new application can load newly persisted objects without any problems. But when it loads legacy objects, a player with a level, when it really expects a rank attribute, the level data is lost and the rank is set to 0. Alas, we have lost valuable data. Developers need to be very disciplined to avoid these kinds of problems. So, Controvol to the rescue. Controvol is an Eclipse plugin that type checks all changes to class declarations against the code history in the code repository. In this concrete example, it issues a migration warning and shows the conflicting class declarations side by side. Controvol not only detects the issue, it even proposes quick fixes to resolve it. Let's say we choose the second option, which will add migration annotations such as supported by the object mappers Objectify and Morphia. Then the annotation also load that is automatically added will also load level attributes into the rank attribute. The new class declaration thus matches old and new players without any data loss. Even better, it migrates legacy data on the fly. This is called lazy schema evolution and is supported by several object mappers designed with NoSQL data stores in mind. To sum it up, Controvol is an interactive Eclipse plugin. It implements its own type inference system and type checks class declarations against their history in the code repository. Controvol detects common schema evolution problems prior to launch. In our demo, the audience can try for themselves how migration problems come about and how Controvol can detect and fix them for them.